Hello, Algebra 2, and welcome to Lesson 12. Woo! Overcoming obstacles in factoring. There are no obstacles. You just can't factor some things. All right, here we go. So let's go ahead and find all real solutions to this particular equation. So the first thing I see is that I have two quadratic expressions there, right? In my parentheses. It turns out that if I was to multiply that out, right, I would have a fourth order polynomial. But what's really important is to see, can I factor these things more completely? So I'd like to check and see, right, if you're with me on this, if you like this method, I'm going to look at that and say, hey, are there two numbers, I'm looking at this first one, are there two numbers such that if I multiply them I get 3, and if I add them I get -6? No, definitely not. Because 3 only has the factors 1 and 3. And those two things could never combine to get a -6. So that means that that guy is not factorable. So what am I going to do? I personally really like completing the square. You could use quadratic formula as well, but completing the square is so neat and so easy with this one. And the coefficient of x squared is 1, which means that I can complete the square if I want to. So I'm going to set it up with a little blank there, right? And then I'm going to subtract 3 from both sides, and I'm going to need another blank there. Remember, when I'm completing the square, the thing that goes in that blank is c, which is going to be equal to b over 2 squared. So in this case, c is going to be -6 over 2 squared, so 3 squared, or 9. Boom. Boom. So right, if I add 9 to one side, I needed to add it to the other side. So that's completing the square right there. All right. The reason why I am completing the square is because I want to express this as the square of a binomial. So there we go. There it is, right? Remember, this value right here is the square root of c. Very bad arrow. All right, there we go. And remember, if this guy right here is negative, right? If the coefficient of b is negative, then this sign right here has also got to be negative. If you like quadratic formula, you just go ahead and knock yourself out and do that. I think that this is much less work, because now all I got to do is take the square root of both sides. Boom. Add 3 to both sides. Is 6 divisible by anything that has a square root? Is it divisible by a perfect square? No, so it's just going to stay like that. So then my solutions here are going to be x equals 3 plus root 6 and x equals 3 minus root 6. All right. Okay, so I found all of my zeros, right, of my first expression in there. Now let's look at this one. First of all, every single time I'm going to check, is it factorable? So -14, right, a times c on the top, on the bottom, b. Are there two numbers that multiply to -14 but add to -4? So factors of 14 are 1, 14, and 7, and 2, and that's it. So that is a no. So that means that this is not factorable. You see why we're overcoming difficulties in factoring? because they're not factorable. That is difficult. All right. So now I used completing the square with the other one because the coefficient of x squared was 1. Not so nice to use completing the square when the coefficient of x squared is not 1. So I'm going to go ahead and get out my handy-dandy quadratic formula for this one. Remember, my quadratic formula is x equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. All right. So in this case, with this guy, right, A is equal to 2. B is equal to -4, and C is equal to -7. Let's go ahead and plug those bad boys right into this thing. So X is going to be -4, right, or the opposite of -4, +4, plus or minus the square root of, again, -4 squared minus 4 times 2 times -7. All divided by 2 times 2. Okay, let's work on simplifying this guy right here. Or this expression. Who knows if it's a guy or not. Anyhow. Alright, 4 plus or minus the square root of... Alright, that's 16. Yes, I'll just put it in there. Alright, 16. And then we have -4 times 2 times -7. So that's 28 times 2, or 46. And it's going to be positive because I've got 2 negatives there, right? About 56. Alright, 56. That's much better. All divided by 4. Bring that equal sign over here. So that's going to be 4 plus or minus the square root of 72. All divided by 4. I'll split that up. 4 over 4 is 1, plus, is 72 divisible by something that has a square root? Yes. You might say 9 right away, but I'll tell you there's a bigger one. It's 36. So that's the square root of 36 times 2 over 4. Just working this up. The square root right here. You can see why I love completing the square. It's less work. So that's 6 root 2 over 4, which turns out to be 1, plus 3 root 2. Simplifying that fraction, right? 6/4 is the same thing as 3/2. So now I have my 2 answers. My answer is that x is equal to 1. Not sure why I ditched my plus or minus over here. I think I was being hasty. But the idea is that I have 2 solutions. 1 plus 3 root 2 over 2. And my other solution would be x equals 1 minus 3 root 2 over 2. And there we go. We have 4 solutions. These are also the zeros. So it turns out that if I plugged these in their expressions that I solved for, I would wind up getting 0, right? And we would say 0 equals 0. And we have done it. Fantastic. Let's do another one. Another one? Another one. Here we go. Hey, let's factor and find all real solutions. So, I just heard the magic word. Hopefully they're actually factorable. That would be just fantastic. Hey, why are you telling me to factor this? Well, let's leave this one. Are there 2 numbers such that if I multiply them, I get -4, and I add them, I get -2? No. No such numbers exist. So, well, again, if the coefficient of x squared is 1, I would much rather complete the square. So let's find our 0, set it equal to 0. So x squared minus 2x plus some number c is going to be equal to 4 plus that same number c. Remember, over here, I'm just writing it down here. C is b over 2 squared, which is going to be 2 over 2 squared. So I'll put a y1 there and y1 there. Fantastic. Hey, now I'll express this as the square of a binomial because that is indeed a perfect square trinomial. X squared minus 2x plus 1 is a perfect square trinomial, which means that I can express it in this way. There we go. Hey, I'm going to take the square root of both sides. I'm going to add 1 to both sides. And now my two solutions are going to be x equals 1 plus the square root of 5. And x equals 1 minus the square root of 5. Yes! Alright, so now I found all of my zeros for my first little term in the parentheses. Now, let's find all of my zeros for this bit of nastiness. Again, it said factor, so, I don't know, maybe they really mean it's factorable. Maybe they're crazy. So, I'll put a times c, right? And we're looking at this one now. So, a times c is negative 9. I mean, that looks not like a very good negative 9. There we go. And b is 8. Hey, I think this one works. I could have positive 9 and negative 1. Yes. That means that it is indeed factorable, right? Which means that I can find my solutions by factoring. I'm going to go ahead and use the Xbox method. So I'll put my 3x squared here, my negative 3 here, and again that 9, this 9 goes there, and this negative 1 is going to go right here, except for I'm going to give it a variable as well. I'll find the greatest common factor of my column. Greatest common factor of this column is going to be 3x. The greatest common factor of this column is going to be negative 1. Greatest common factor of this row will be x, and the greatest common factor of this row will be 3. And so there it is, it's factored. So this thing is actually equal to 3x minus 1 times x plus 3, which means that my other two solutions are going to be x equals negative 3. And if I solve 3x minus 1 equals 0, I'll have that x is equal to 1/3. Boom, 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 and whoosh. We did it. Hey, let's do more. These are fun. Let's find all solutions to something new, something different. That's not a quadratic, and I don't see any quadratics in there. What am I to do? What am I going to do? So what we've got to do is factor by grouping. You guys definitely learned this in Algebra 1, but we're going to review it, okay? Factoring by grouping. Okay, that's what it's called. I'm going to write it down for you. We're going to factor by grouping. Special one. All right, what that means, when I'm factoring by grouping, I'm looking at this thing as two different things. And so I'm going to go ahead and factor each of these separately. So I'm going to factor x cubed plus 3x squared. And I can factor a monomial out of that. The greatest common factor of x cubed and 2x and 3x squared is going to be x squared. X cubed divided by x squared is x, and 3x squared divided by x squared is 3. No, actually, I'm not going to leave that plus sign in there because I think I might like to factor a negative number out of this since they're both negative. And that's a little forward thinking because I want to factor a number out of the expression 9x minus 27 in such a way that I wind up with x plus 3. And it's going to work. It's going to happen. Okay, so I am going to factor out a negative 9. So negative 9x divided by negative 9 is going to be x. And negative 27 divided by negative 9 is going to be positive 3. Look at that. That's what I wanted. I need these two to be the same. That's how factoring by grouping works. If I can't do that, factoring by grouping will not work. So that's good news. Then what I'm going to do is it's pretty much like I'm factoring an x plus 3 out of both of these. So I'm going to go ahead and do it, and then I'm going to explain to you why it works. All right? So I'm going to factor this like this. So this actually becomes x squared minus 9 times x plus 3. So that actually works. Now imagine this. Imagine if I was to let x plus 3 equal a, for instance, right? Then I would have x squared times a minus 9 times a, right? Right? Equals 0. Imagine that, right? So can't I factor an a out, right? And call this a times x squared minus 9? That's how factoring by grouping works. So, and we said a was x plus 3, right? So I wind up with x plus 3 times x squared minus 9. That's what's happening when you're factoring by grouping. You're just factoring something out, but it's like a big thing. You don't normally, you maybe haven't factored out an x plus 3. I could factor out all kinds of crazy stuff. It's just that they have to be the same factor. So because of this, I know that one of my solutions is x equals negative 3. But this one poses a whole other problem. It presents to me a whole other equation that needs to be solved. And that is this one, right? I need to know what value of x would make this 0. So I'm going to go ahead and add 9 to both sides. And take the square root of both sides. Remember, the square root of x squared is just x. And also, when I take the square root of both sides, I need to consider both positive and negative values. So here we go. I have my two solutions now. X is equal to positive. Square root of 9 is 3. So I have x equals positive square root 3 and x equals, x equals positive 3, which is the square root of 9. And x equals negative 3. So this particular thing has how many solutions? Only 2. Only 2. Because we repeated the x minus 3. Why did that x minus 3 repeat? That's kind of weird. And this is why. Isn't it also the case? So this here is one way of solving that. It also turns out, though, that x squared minus 9 is the difference of squares, right? So that's x plus 3 times x minus 3. So in this particular equation, I actually have x plus 3 with a multiplicity of 2. So I could even write this. I could rewrite this equation like this as well. So I could write it as x plus 3 times x minus 3 times x plus 3 equals 0, which turns out to be x plus 3 squared times x minus 3 equals 0. So there's a couple different ways to look at that and get it done. Whew, let's do another one, because we just love this practice on factoring by grouping. I kind of like doing it, I gotta say. But it's fine on my own. Here we go. I'm going to eliminate all these things because I'm going to take this one. It should be in your notes. Forever. Here we go. Scotty! Hey! So glad that you could make it and join us today. What's that? You want to do a problem today? Fantastic, guys. Welcome Scotty to the room.
Hey, what is on your ma? I love it. I'd like to do a problem today. I want to factor by grouping because I like it. I love it. I need some more of it. Okay, so look, I'm going to factor these. I like to group them. I think these are the ones that I like to factor together. Oh, I'll put a plus sign there. And then this is negative 4x plus 20 equals 0. So what's the greatest common factor of x cubed and negative 5x squared? Well, it's x squared. Look at that. Hey. And x cubed divided by x squared is going to be x. And negative 5x squared divided by x squared is negative 5. What will I like to factor out of this one? Well, I need to have an x minus 5. So, I should probably factor out a negative so that this particular positive sign will become negative. So, you'll think that 4 is the greatest common factor of 4x plus 20. But I want it to be negative. I'm manipulating this. Oh, I wrote the wrong number. Jeez. It's okay, Scotty. Just keep going. Alright, I will. Okay, negative 4x divided by negative 4 is going to be x. And 20 divided by negative 4 is going to be negative 5. Why are you putting a plus sign there? Well, if that, I could check it, right? If I multiply it back out, I'm going to get the same thing. If I distribute back that negative 4. So now that I've got my grouping, I'm going to factor out x minus 5. That's what you said to do, right? I did. Okay. So that'll be x squared minus 4 times x minus 5. Oh, look at that. I see difference of squares. Because this is going to be x minus 2 times x plus 2 times x minus 5. I saw the difference of squares there. Look at that. So my answer then, I've solved it. It's going to be x equals 2. X equals negative 2. And x equals 5. Did I do a good job?
You did. Thank you so much. You're so enthusiastic.
Right, well, I'm going to leave now. I've got other things to do today. Bye.
Bye, Scotty. All right, well, let's go ahead and do the last one in a little peace and quiet. Guy's going crazy. It looks like I need to factor by grouping one more time. Here we go. Again, I'm going to factor x cubed minus x squared. Right? I'm going to group those together. And I'm going to factor negative 2x plus 16. I'm going to group those together as well. Okie dokie. It looks like the greatest common factor of those is going to be x squared. X cubed divided by x squared is x. Negative 8x squared divided by x squared is going to be negative 8. And now I need to look at this one and decide, the greatest common factor is 2, first of all, right? But now I need to decide, do I want to factor out a negative 2 or a positive 2? Well, I really need this to be positive, right? So I think if I factor out a negative, that's going to make it positive. And you kind of have to think ahead with these things, okay? All right, so I'm going to factor out a 2. Negative 2x divided by 2 gives me positive x, and that's what I wanted, right? I need these two things to be the same. So that's why that's crucial when I decide whether I'm going to factor out a negative or a positive. All right, so positive 16 divided by negative 2 is going to give me negative 8, and that was exactly what I wanted. All right, and it turns out that now I have, I factor the x squared minus 8 out, and I wind up with x squared minus 2 times x minus 8 equals 0. And x minus 2, that is not difference of squares, right? Not difference of squares. So clearly one of our solutions is x equal to 8, and the next solution I can find by solving x squared minus 2 equals 0. I'll add 2 to both sides. I'll take the square root of both sides. And there is no whole number solution to that, or no whole number value for the square root of 2. So I'm going to call this, my first solution will be x equals positive square root of 2, and x equals negative square root of 2. So I have 1, 2, 3 zeros or solutions or roots, whatever you like to call them, to this particular equation. We did it. Yes! Perhaps next time we'll be visited by Dr. Brahmgupta. For now we're done. We'll look at this problem tomorrow. Hey, stay good. Try to find the happiness in everything. Have yourself a wonderful evening. See you tomorrow.